Okay, back to the labs. We're into phase 3, configuring the internet connection and VPN tunnel. Internet connection, huge part of the CCNA. VPN tunnel, totally outside the scope of the CCNA, but huge for the real world, and was a big thing people wanted to know about on the feedback. So let me bring the lab over, and we'll just start working through it together. You notice, first of all, let me just use the lab to talk. Uh, Here's the lab itself. You notice that we've now expanded. We've got the branch office, which has an internet connection, which I want to show you a little bit about how I did that in GNS 3. And then I brought in the corporate office. So we're going to bring up a connection to the corporate office using a VPN tunnel. Now, I've never done this in GNS 3, so I'm hoping it supports all the encryption. But if not, well, let's hope it will. So we're going to bring up a VPN connection between the two. And then, of course, get the internet connection running. Now I've gone through most of this lab as I've done before, but we may run into a line that needs to be changed. So we'll kind of work through that as we did the last time. So here's our scenario. Following your advice, Nugget Labs branch office has installed 50 megabit per second DSL connection. They'll be using a VPN connection to tunnel back to the corporate office, or to kind of bridge the connection of the corporate office. And I want to make sure. I was sitting here thinking about this. Just last night. As we're talking through this, I want to make sure that we don't miss the big picture. Remember, we are network people, right? When you're working in Cisco, you are a network person, and your goal is to lay the fabric that everything else runs across. Now, sometimes we can get so wrapped up in our little world that we forget about the fact that people are actually trying to get a job done. I'm like, hey, I've got everything working. This is fantastic. I can ping. And then someone's like, well, can I use my SQL database to go across there? And you go, oh yeah, there's people using this network too. It's not just to ping. So remember, we are building the fabric, essentially the road that everybody goes across to communicate across all their devices, their PCs, their servers, everything like that. So we are now unifying. We've built the fabric, we've built the infrastructure for the branch office in the last lab, the phase 2, where we rolled out the VLANs, we rolled out the switches. Now, as of right now, we've got layer 3 switching going on. Everybody can access everything. There's no restrictions on access yet. That'll come later. But we're now going to link in the corporate office. So by the time we're done here, not only will people be able to surf the internet, but they'll also be able to connect from the branch office to the corporate office. Now that's pretty cool, because when you get beyond the pings, that means, wait a second, we have unified voice over IP, to where once the voice over IP folks do their job, we can now call using 4-digit extensions or 3-digit or whatever extension numbers people are using in this network across between these two offices completely over the internet connection, rather than using any phone lines at all, which is pretty awesome. We now have a linked fabric to where people can access servers at the corporate office. Vice versa, people at the corporate office can access servers at the branch office. So we're starting to see this emerge into a business solving situation. So that's just the big picture I wanted to bring back into focus, because sometimes we get, well, I'll say personally, I get so focused on packets and pinging and wow, look at that I'm like, oh yeah, this is for a purpose. So let's now look at the requirements. And actually, before we get into this, I want to talk a little bit about GNS 3. First off, I want to tell you how I spent the last hour of my life. When I built this topology, it was all working last week when I built it, and when I powered it on today, the Dynamips, essentially the engine behind GNS3, crashed, and I spent the last hour just tinkering and troubleshooting, and it seems to be, at least right now, that if I power up every single device, I didn't count them, but we'll say 10, 11, 12 devices, like somewhere around the 11th device or so, Dynamips crashes, and I can't access anything anymore, which was very sad. So what I did, I finally, after an hour of searching and Googling, I just said, forget it. And so that's why Switch 3 is powered off. So if you're wondering why is Switch 3 down, well, that's why. We just had a little GNS 3 issue. And it's funny because I saw online there's some people having the same issue, and no response is helpful on there. So I just said, well, we don't need Switch 3 for this lab, so we'll figure it out as we go. So That being said, that's why switch 3 and PC2 are off. Now let me talk about what I've done with the clouds, and this is pretty sweet. So this cloud, let me bring over the node types. You can see that we've got this little cloud that you can drag and drop anywhere on here. The cloud in GNS3 represents a connection out of GNS3. This is where GNS3 becomes real. Here's what I mean. When you configure a cloud, let me double click on this real quick. I'll bring up the configuration for the cloud. You can see that I have the ability to link GNS3, or to link essentially this connection. You can see the link from router 1 to the cloud is actually bridging to a network card on my computer. I've got a little Realtek PCI gigabit Ethernet family controller, this big old long connection here, description that comes up. That is actually the network card on my PC. So what this does is bridge router 1 into my network at my house that I've built. Now, at my house, let me just give you an idea here. At my house, I'm running the 172.30.100 network. So what this does is bridge router 1 into 172.100.30, which will then allow router 1 to access the real internet, because of course my house is routed, and if I go out here I can ping google.com and whatever else, and I'm able, wow, that's slow, but I'm able to get out and access the different devices. So here's what I did. You can't share a cloud. At least I didn't find a way in GNS3, and I wouldn't call myself a GNS3 expert, but I've tinkered with it enough. So what I did instead was bridge another cloud, and I bridged it to the same network adapter, and brought the corporate office in. So the cool thing is, these guys, as they are now connecting to these clouds, are actually getting real addresses from my real network that is able to access the internet. Now, it's not a public address, and that's okay for this lab purposes. I'm sure I could set up a VLAN and all that madness here, but I'm not gonna do that. These guys will have quote unquote public addresses, and they can actually communicate over my home network, and they will be able to get out to the real internet. So that's pretty fantastic. That little cloud icon is an amazing thing, to where this can now become a real topology. So I wanted to first off convey that to you, and now let's get into the lab. So the requirements of this lab is we're now going to be configuring the Nugget Labs branch office router. Now this router, again right here in the picture, does not have any configuration at all on it. It is, do you want to enter initial config dialog? So we're going to configure that router initially with a base configuration. Now, we did this before, but again, repetition is huge when you're learning. So I'm going to configure it with a base configuration, host name, passwords, logon banner, all the same stuff we did for the switches. I'm going to go a little faster this time so that we can get through a little more material than talking through each one of those line items. And then we'll start configuring the IP addresses and get things connected. So with that being said, I'm going to bring I'm going to bring up a new answer key, since we're into a new lab here, where we'll type all the commands that we're doing as we go. So let's just put a little flag in here, and we'll put phase 3 answer key. All right, so we're starting off on I'll just transfer the pieces as I type them. Nugget Labs B1 RT1, and I'll give you just a heads up. In the real world, you usually want to do the opposite of what I'm doing right now, which is once you are a Cisco ninja, you'll be able to come into Notepad and go, okay, config T, host name, Nugget Labs B1 RT1. You'll say, okay, interface. You'll know without being in the console the commands that you'll need, and you'll type them in here. You'll verify them. You'll have a buddy check over them, make sure everything looks good, and then paste them into the router. But we're going a little backwards here. I'm going to go from the router and then paste them into Notepad, simply because I know a lot of you don't have super Cisco experience to be able to type all that. Some of you do. That's no problem, but this is how we'll go about it, so we can use the context-sensitive help to help us through. So first thing, let's just do 3 in a row: host name, passwords, and logon banner. So console VTY enable. Here we go. Global config mode, host name will be NLB1 RT1. This will be the branch router. And look at that, we've already got a duplex mismatch. Look at that. That's actually my router I have at home. That's the one that's allowing us to get to the internet. So router 1 is seeing through the cloud via CDP, and CDP, by the way, is the piece that detects these things. Cisco Discovery Protocol is like, whoa, do you know that you're not full duplex and the UC520 is full duplex because I have it hard coded. So we'll fix that later. Well, let's just so we eliminate those messages. Let's fix it now. 0/1. Duplex full speed 100. There we go. Just hard code those pieces. Okay. So that should solve that message as we go. Now let's get back to the lab. So passwords logon banner. Okay. Bring it back up. Enable secret Cisco. Line console 0. And I've done this base config so many times, my mind goes on autopilot sometimes. This is one of the things that was on there, which is synchronous logging. So I'll just do all the things under the console port. 3-hour console port, synchronous logging, get all that out of the way. Exec timeout 3. Wait a sec. Nope, that's minutes. So 60, 120, 180 on the exec timeout. And password Cisco. Good. So let's say exit out. Line that takes care of the console port. VTY 0/4. Password Cisco. And I think, did it say aux port as well? No, it didn't, but why not? We're here. On a router, every router has an auxiliary port you can use for a modem connection where you can tie a modem in. You can actually even use that as a kind of console connection, kind of like a little backup. But it represents a way that people can get in without a password. So let's secure that. So we've got the VTY, the console, the enable secret enabled. Let's do a logon banner. Banner MOTD. Let's use ampersand. That's fine. And I'm going to steal it from here. What was our logon banner before? There we go. Simple and direct. Do not log in. Paste that in there. Ampersand. Good. Okay, so we've got hostname, passwords, logon banner, 3-hour console port timeout, synchronous logging. Okay, Telnet and SSH is enabled. Use nuggetlabs.com as your domain. Admin Cisco for SSH credentials. Okay, so what we're going to do here is I'll do, in no specific order, IPSSH version 2. Oh, I'm doing it out of order. So we've got create RSA enabled to enable SSH. I need to but this is what if I were to use that command crypto key generate RSA, it's going to say, whoa, you got to configure a domain name first. So I'm going to do IP domain name. Let's do nuggetlab.com. Is that right? Nuggetlabs plural.com. Nuggetlabs.com. Enter. Now I can do the crypto key generate RSA. We'll use 1024 as our modulus size. And I got to start putting this stuff into Notepad. Oh, SSH. Well, I usually do IP SSH version 2 just because I do. So we've got SSH version 2. Let's create a user account. Username, admin. Instead of typing password, which is clear text, let's use secret, Cisco. So we've got username, admin. Password Cisco for SSH. Looking good there. So now let's go under line VTY 0/4 and we'll do login local, which says use the local user database for logins to this port. And then we'll do transport input and we'll allow both SSH and Telnet. Did I do this before? I'm having a mind blank right now. I don't know if I did that on the other switches. But that will allow both SSH and Telnet to access this port. I think that's it for enabling. Hang on, let me just look again. Telnet SSH enabled. Nugget Labs admin Cisco is SSH. That's good. So HTTP management disabled. Let's exit back out. No IP HTTP server. Turn that server off. DNS name resolution set to 4222 and 4223. So IP name server 4222. And if you're sitting here watching me going, dude, what are you doing? This is too fast. Go back to phase 2 lab. I actually explain line by line. So what I'm doing is previously I think this piece took me like 40 minutes because I explained each piece what I was doing. Now I'm just going through it. So we've got the 2 name servers set. Let's do the clock set. So I'll exit back out. Merry Christmas. It is December 21st. So let's do clock set. It would be 10:06 in the morning on December 21st, 2011. Config T. Oh, I got a MacBook Air for Christmas. Just thought I'd share that. Okay, so by the way, those things are phenomenal. Just built machines. Those MacBook Airs, they're great. But I run Windows on them. Isn't that sad? I booted up into Windows. It's the best Windows laptop I've ever owned. Where was I? So clock set. Okay, NTP server is going to be, what was it saying? Use this guy, which is pool.ntp.org, one of the addresses that goes to pool.ntp.org. So that will be that guy. So NTP server. So let's do a show NTP associations. We see that server's configured. Of course, it's actually not going to work. Actually, hang on. Let's do a show IP interface brief. Look at that. By the way, I don't know if you knew this or not, but if you have a fast Ethernet interface on a Cisco device connected to a network that does have DHCP services, it will automatically power itself on even if the device has no config. So I know it throws a lot of people. Notice it says DHCP assigned this to me. What that means is when I booted up, who would say something like that? When I booted, when I loaded router 1 right here, it had no config, but it detected that there is a DHCP server on this connection and it's getting an address. So this one will automatically change the status of its interface to up and receive that DHCP address, which I know a lot of people are hard-coded like, oh, well, Cisco routers are shut down by default on all interfaces, which is true unless you have DHCP server on that interface. So you notice that's where that one came up from. And our first clue to that was early on. It was saying, hey, you've got a duplex mismatch. That would have never happened if the interface was actually powered down. So that should tell you, hey, we've got an interface running there. So maybe let's just do a show IP route, because here's another interesting fact. Sometimes, that's interesting. Sometimes, I'm just curious. But not this time. Sometimes Cisco devices, if they have no config and receive an address via DHCP, they'll automatically set their default route to be whatever the DHCP server is assigned as the default gateway. Not so in this case, and that's okay, because we're still just doing the base config. So that's now, let me just verify and then I'll paste them all. We've got the hostname, passwords, banner, 3-hour console timeout, synchronous logging. This is enabled, telnet and SSH, HTTP management disabled, DNS resolution is set, and the clock is set. So let me add those to our answer key and then we'll move on. Okay, so I've put everything into the answer key, showing all the commands in here. Just want to mention one quick note, is when I got to the end, I did the NTP server such and such, and then I typed in end, which drops you back to privilege mode, because that's where you set the clock. But I put the command in the answer key so you'll see it, but obviously you wouldn't want to paste that in there, because by the time you see this, well, even now, it's no longer 10:06 in the morning on December 21st. It's 10:13. So that's all the commands that we've used so far in setting this up. Just want to make sure everything makes sense in there. I put in this 1024 again because if you're pasting this config in, you might remember crypto key generate RSA asked what size of keys. This is not a command. Actually, maybe I should put it. Well, I don't know if the space will mess up the answer, but you can't just type in 1024 in global config mode. This is the answer to the question it asked, so you can paste that in. So now let's configure the interfaces. So we've got the IP addresses for Nugget Lab Branch 1 RT1 should be configured as follows. So 10.1.254.2/30 will allow us to communicate right here to switch 1, which is 254.1/30. You remember we did that early on in the Phase 2 lab. So this will be their own little point-to-point subnet. And then even though it got a DHCP address, I wanted this one to be 172.30.100.230, so we can know it's a static address. 230, we know what that is. So piece of cake, let's jump on to router 1. interface FA0/0, IP address 10.1.254.2. No shutdown. Get that powered up. And then interface fast Ethernet 0/1. And let's do IP address 172.30.100.230. Class C subnet mask. Now it's kind of hanging there because it's going, wait a sec, you're changing an IP address on me. Is this okay? It's verifying something. By the way, whenever something hangs like that on a router, no matter who you are, if that's a production router, you will have that lump in your throat going, did I just crash the router? Take heart. It doesn't always mean you crash the router, but often it does. So let me actually fix this. Let's go into fast Ethernet 0/0 and speed 100 duplex full. So it doesn't have a mismatch now with switch 1 over there. So now we should be able to, let's do a show IP interface brief. There's not many interfaces here. We should be able to do some testing. I'll do a show CDP neighbors. It sees my UC520. That's actually my my device that connects my home to the internet. I've got switch 1 that it sees, and it's seeing router 1, the corporate router, through the cloud. And that's simply because this cloud is an invisible device. It's usually you only see directly connected, like you would see like a switch here or something like that, but it's an invisible device. It doesn't actually stop the CDP messages. So I can even see across to the other side of the cloud, which is got corporate router 1. So let's do some pinging. Let's do a ping. Let's do a show CDP entry, first of all. Nugget Labs B1, and I'll just put star, which this shows from the CDP output anything with NLB1, which will be a lot shorter than typing that whole name right there. Oh. I was thinking, I didn't expect that to happen. It's a dash instead of an underscore. So my inconsistent naming convention messed me up. So I'll do a ping, paste in switch 1, make sure that we are getting there. We are. Good. Then let's go ahead and ping. Well, let's just ping my default gateway. Ping 172.30.100.1, which is the gateway to the internet, and we're there. So we're communicating on both sides of the network that we see right here. Good. So in a blink of an eye, I've added those to the configuration here. Answer key. Now I do want to mention, of course, this is specific to my home environment. That's why I said let's set the IP address to this. But if you truly are doing this at your house, which I highly recommend, or your office, or wherever you are, you might want to change this to an address that is relevant to your environment. I mean, in your environment, you'll have the cloud here connect to your home or your corporate network. So obviously my addresses, the 172.30 subnet, is not going to work there unless you happen to use the same subnet that I do at my house, which then we're IP address buddies. Okay, so let's move down. So now I've got next step in here. Configure a static default route on Nugget Labs B1 RT1 using the IP address of the ISP router, which is this. So it's saying we need to configure a default route out now, meaning allowing this guy to reach the internet. So it says once this default route is in place, RT1 should be able to ping the internet addresses. It should be able to ping internet address like the DNS server 4222 or Google's copy of it 8.8.8.8 that they have as a DNS server. Just a couple sample addresses I use all the time when I'm testing corporate environments. So this is just one command. I go on router 1, global config mode, and I'll do IP route zeros. Again, saying no IP address, or any IP address is more accurate, and any subnet mask will route to 172.30.100.1, which is the default gateway. That's it. So now I can do a show IP route, and I see my default route is now available. I see a little static default flag there. So let's try it. Let's ping the internet. Wham! Look at that. 4222.3. Ping 8.8.8. Oh, 8.8.8.8. You wanna see the kind of thoughts that go to my mind? Let me show you something. I have a blog called Techcert that I post on. Some of you might know about it, some of you might not. I post on it maybe once a month, sometimes just when I think of something. And one day I was just feeling it, and I created a whole post on why 4.2.2.2 will always beat 8.8.8. Will always be a better DNS server just because you can type it faster. So 8.8, sure enough, we are getting success from there. So we are getting internet connectivity. As a matter of fact, let's do a show NTP association. Oh, it hasn't synced yet, so it's still configured, but it has yet to sync with that. I'm just curious, can we ping the NTP server? Oops. There we go. Good. And so it's actually reaching the NTP server, so it's just a matter of time. NTP, oh, there it is, to pull an Ace Ventura quote on you. So we've got this now synced, so now I can do a show clock and find out, look at this, I'm synced up with well, universal time coordinates, which is the center of the world, Greenwich Mean Time. So this is not my time, but I will tell you, a lot of people keep their devices on UTC because they have devices in different time zones, and they want one time that they can reference so they know the time across the board. But most of the time, for instance, if this is a local to Arizona office, I would go in and I would do clock, time zone, and I would say the name is Arizona, and you can choose whatever name you'd like. And I'll do, we are -7 from UTC. I believe that's what we are. Hit enter. Now I'll go back and do a show clock. And now it's the correct time. It's 10:22 in the morning on that. But now I'm getting into the bonus material. But that's great to see that we now have an NTP association is syncing up because we have internet access. Our time is being set to the second accurately. Man, I'm excited. I'm like, what else can I type? We can make sure the DNS is working, so I can ping google.com, and I see, sure enough, it's resolving Google via our domain server that we configured. So this is cool. We actually have a working internet router in our little GNS3 topology. Excellent. So let me see where we are. We are actually at a good point to divide, but let me do this one more thing. Configure a static default route on switch 1 using the inside IP address of router 1 to reach the internet. Squish it over a little bit more. Now it's saying, let's go to this switch. So this guy has a static IP address to reach the internet, or static default route. Let's go to this guy and create a static default route to the to router 1, saying go here to reach the internet. Let's do that, and then we'll break. So come over here. Let's go to switch 1. Enter a couple times. Get into privilege mode. Let's do a show IP route, just seeing where he's at right now. Switch 1, that's interesting. Wow, I bet you I never converted this guy back from when we did the router on a stick conversion. I'll fix that later. It's not a big deal as of yet. So let's go into global config mode, IP route, all zeros. To 10.1.254.2, which is router 1. So I'm saying, let me clear off some of this gibberish. I'm saying I'm going to go to router 1. I'm going to go right here to reach the internet. Okay. Who thinks it'll work? Meaning, no, I should tell everyone say, what work? No, if I go on here, I've got my default route. Let me do a show IP route. I've got my default route saying send everything to router 2 or router 1. I can ping router 1. I'm getting there. Who thinks if I do a ping to 4.2.2.2, it'll work? Show of hands. Lift your hand. Do you think it'll work? I say, okay, 1, 2. How many more? Okay, you. Okay, got it. Okay, so some of you think it'll work. Some of you are not lifting your hands. It's not going to work. Now the question is, why not? Think this through with me. Why is it not working for my switch, who is now pointing to router 1 to get to the internet? How come he can't ping 4.2.2.2? Well, right here. Some of you are screaming the answer, I know it. It's NAT! This is 172.30.100 subnet. Now, this is the ISP. Well, pretend this is not a home network, because really in reality it's not for this environment. So this is this is going to the internet. This is 230 right here, and the ISP is .1. Inside of here, I've got the 10.x addresses. So what's happening is this guy is pinging from a source of 10.254. What was it? 1.1. I think is his IP address, hitting the router. The router sends him out here to the ISP without changing his address. He's still coming from 10.254.1.1, which the ISP and my router, in my house, is seeing that address. It's going, I have no idea who you are. Now, if this were a real ISP, the router would say, I have no idea who you are, and I have an access list here saying to destroy you because you're an RFC address, RFC 1918 address. You're a private address. You can't do that. So before switch 1 and any device here in this topology, before any device inside of our network will be able to ping the internet, we have to have NAT configured on router 1, and that is going to be done in the next nugget. So for now, we've got the base config laid down, IP addresses assigned, we've got the static defaults route configured on router 1 and switch 1. Next up, let's set up NAT. For now, I hope this has been informative for you, and I'd like to thank you for viewing.